hope you're enjoying your day so far over here. Been productive, useful. Looking forward to the award ceremony in the afternoon. Who is hoping to win? Yeah. All of us, should I say that? Yeah. Okay, so a quick round of kind of getting to know the audience. Are you guys all students over here? Second year? Oh, only few second year? Third year? Okay, and who's specializing in AI, ML, DS? Oh, so I'm speaking to elite audience here. Okay, good to know. So then I can set the pace accordingly. Don't hesitate to tell me that you know all of this. You can just get off the stage. We don't need you. Everything is okay with me. I will keep the session interactive. You guys please participate. Right? And as I said, do not hesitate. Just brush me off. So let's begin. The title that I was given is Programming with Gen AI. I think everybody here knows Gen AI, right? So I can't, or I don't need to rather talk about Gen AI. We will make this also a hands-on demo session, which also, okay, let me ask, how many of you don't know what is VectorDB? You don't know VectorDB? Have you heard? No? Okay. How many of you don't know RAG? I thought all of you are using RAG, right? No? So these are the buzzwords that you all know from the Gen AI craze that's catching up with everyone. So we'll talk about them. Just first few slides to introduce Gen AI. The takeaway I want you guys to take from the talk today is, catch up with the buzzwords. It's obviously helpful, needed for your future careers to be up to date on all these technologies. That's what will bring food on your tables. But you also need to be pragmatic. You need to be business driven in whatever you do. So you need to kind of identify your problem first on what you're going to work on. The use case, the business team will help you to pinpoint that, and that's when you will start developing solutions towards that problem. So keep that the very practical aspect of the problem that you're solving always in mind, because that will help you to keep things simple, focused, and directed, achieve your goals faster. Right? So that's what the main thing I need you to take from here. I'll not talk about that so much, but that's the underlying theme all through. Okay. So Gen AI has been, the craze, as I said, the last 1 year for sure, 1.5 years. Do you know when did the whole society become aware of Gen AI? ChatGPT, when was that? October 2020? 22? Okay, so November 22 is when ChatGPT came out, right? So that's when everybody knows about that. So I have a slide on that, but I can just talk since we already brought up ChatGPT. Everybody knows what the ChatGPT stands for? Or we are just users? Do you know what chat is? I think kind of obvious. What is a G, P, and T? Okay, so at least we have that clear. So I'll then not spend too much time with that. So a few months ago, it was more like, okay, there is something called ChatGPT. Looks like it's going to catch on. Should we here being the executives and the business leaders of any organization, right? So they were unaware of what it is, but they just felt that it's getting popular. We should use it. We should be, catching on to that and use it somehow. To now, it has become more mainstream. Everybody is aware that that will be a significant contributor to their business. They need to integrate. How can we integrate with our existing systems? How can we make it more safe for our system so our data doesn't get leaked and so on? Right? So who should we partner with? Who can provide us Gen AI services? How do we balance the risk and value that ChatGPT? I'll use ChatGPT for lack of, just for the convenience, everybody is aware of that term. Right? What are the tech stack? How do we integrate with our existing systems? Right? So just a motivational slide. This is only the numbers for India. Shameless plug-in for my company over here. Right, India itself stands to gain in GDP beyond our imagination, what we'd have imagined a couple of years ago. impact for you as developers, I'm mostly talking about you in that persona, not as users, because all of us here are going to one way or the other interact with, being in CS domain, we will be interacting with such kind of systems as developers. So what you can use ChatGPT and such systems is for 4 main C's, 4 advantages that such systems bring to us: concision, code creation, customer engagement, and creative content. Right? So that's more of a marketing language, 4 C's, but I think all of us are aware of what these stand for, what they are, how we use ChatGPT for each of them. Right? How do we use for concision? Summarization, right? That's what everybody uses. Then we have code creation, coding. Okay, well known. We all use ChatGPT for giving us code snippets. Then the customer engagement, chatbots basically. So there were chatbots even before ChatGPT came around, right? What's the difference then? Sorry? No, chatbots were automated, right? Answers were predetermined. Okay, very good. So I will pass something around. Just some small goodie for you guys. So, right. So basically, before ChatGPT came around, the chatbots that we had were more of rule-driven entities. We were programming them to extract the intent of the user from what the user was talking about, and for that intent, there was a pre-specified answer or response that was given to the chatbot. Right? Now with ChatGPT, we make it more natural. Right? We don't need to pre-program the rules. The system understands the intent from whatever language the user might be speaking in. Right? And the last one, creative content. Also, everybody is aware. So I don't need to get into those. Just I thought I'll put some snapshots or cartoons of how ChatGPT has made influence on everybody. So this one here just shows that this is kind of oldish, not a recent one, when the craze was picking up, that everybody has heard about this ChatGPT and it seems to be omniscient, it can do everything, shall we use it? But nobody knows how to use it, what to do with it. Not so much true anymore, but at least. So this cartoon is also a little old. Right? We don't know how to use it, but we know that we have to use it. This is actually more poignant right now. This is where somebody is saying, is it okay for me to copy material from someone else, or does it count as plagiarism, or does it say that I've learned? Right? And the other person says, let's ask that to ChatGPT as well. Right? Why is that poignant? Do you know something in the recent news about that? New York Times, right? So, New York Times, anybody else knows what happened? Have you heard? You know about New York Times at least? What is that? It's a big publication in the US, right? So they sued. Say again?
The data was used
for
without their permission, ChatGPT used their data.
Exactly. So New York Times sued OpenAI for quote unquote using their data for training the model. And what happened is they claimed that the model, the ChatGPT, basically regurgitates the material back in response to questions, right? So very pertinent now because of that. But again, bringing the point out here that it has become our whole soul question answer system. Everything we just ask ChatGPT at this point of time. Right? Is that not true for someone over here? Somebody who doesn't use ChatGPT or switched over from ChatGPT to Bard or any of the other ones? Okay, and this last one is also something that we all do with us, with our lives. Sending an email, we use ChatGPT. Reading an email, also we use ChatGPT. Right? So our attention spans are getting shorter and shorter. We don't want to read anything long. What do we ask ChatGPT? Summarize this for me as if I'm a 5-year-old. Have you done that? So jokes apart, getting a little bit more serious. Everybody has heard, I think I'll run out of time the speed at which I'm going. So I'll just speeden up a lot from here. So AI, ML, DL, right? These are the forefathers of Gen AI. Started with AI. AI, when was the term coined? If you can see here, 1950s, seems unbelievable. But the first thesis, hypothesis, whatever you call, for AI came in 1950s. That time it was hard to believe that there will be systems, but for that time they were rule-driven, programmed, kind of hard-coded, right? I don't know if you guys had heard about ELIZA. Yeah, okay, so that was the first chatbot that was developed. So generative AI, in very brief, basically generative AI, the idea is the generative part, which is there also in the GPT. The idea is that you train on data, and we all know ChatGPT is trained on what data? We just talked about New York Times. Any other data that we know? Anything else? What other data is used for training of ChatGPT? All the data sets. Okay, that's a very nice answer. Sorry? Wikipedia, okay. Okay, anything else? Here, yeah. Wikipedia, anything else? Articles, okay, so that's Wikipedia articles, right? Or any other news articles? Okay, we'll know. Data available on the internet, so basically all the data, right? That's what we can say. Code bases, GitHub code bases, nice, okay. Right, and that's what is kind of opening doors for litigation for OpenAI as well, right? They quote unquote took all this data for training without getting permission. So there is lots of unpublished books that they used, written fictional novels that they have used also for training their model. And that's why when we say give me a story on blah blah blah, we get that story back because it has read, quote unquote, read all these books. So basically the system, the way it works is you have trained multimodal, it could be images. We have trained on a lot of images. That's the DALL-E that we all know, or Midjourney. And train on images, then we give a prompt, which is basically the instruction that we want the model to do. And it kind of scours through all the data that it has and generates the output based on the prompt. Okay, anybody knows about this paper? Attention is all you need? Yeah, okay. Couple of hands, few hands here. So this is the genesis of ChatGPT. That's the T part. This paper back in 2017, way back, talked about transformers, which is where the ChatGPT Foundation started. I'll not talk about it too much. These other novel concepts that this paper introduced, recurrent connections, because we had similar systems, let's say translation systems, RNNs were around, but they had problems in terms of how much attention they can give to previous context. So that's why the transformer avoids that explicitly. There is no explicit recurrent connections in this. Right? So that's the basic building block of the transformer architecture, the encoder and decoder blocks, which are connected, multiple of these encoders, multiple of decoders into the architecture. I have a lot of slides actually, I'll just now breeze through. So GPT 3.5 and 4 is what we are all aware of. There were GPT 1 and 2 before that as well. Have you heard about them? Do you know? Yes? Okay, so that was the first generation, second generation, and even a third generation pre-trained transformer models that are now openly available on a platform called as Hugging Face. Okay, so we can download and use from there, run those models on our local systems. Obviously, as the models have grown, what do we mean by models have grown? The size, which is measured by the number of parameters. You already have one, okay. So the number of parameters governs how much of quote unquote memory this system will have. Right? So more the memory, more it can again regurgitate for us. Has anybody seen this figure? No? What I'm trying to show here is ChatGPT or GPT is not the only LLM that we have in this world. There is almost one new LLM a day that gets published, almost at that rate. LLMs stands for large language models. Okay, very nice. So everybody gets a pen right at this point. Okay, so these various trees of this, various branches of this tree here shows the different architecture. So here on the left side we have encoder-only models, models which only take the left side of the architecture that I showed in the previous figure over here, only the encoder base. So there is subtle difference in the performance or the objective of the encoder and decoder architectures, which we'll not get into obviously over here. So there is encoder-only models, then there is encoder-decoder models, and then there is decoder-only models. Does anybody, can you read where does ChatGPT fit in this? Or do you know from before? Sorry? Decoder only is ChatGPT or GPT in general? Right, we can see clearly over there. So GPT is a decoder only model. We give the context and it kind of quote unquote decodes this to get the answer. This is another view of basically similar information. The point here being the size of the planets is showing the size of the model, right? Larger the bubble, larger is the model. If you can see, there's GPT-4, officially not disclosed what's the number of parameters in that, but 1 trillion plus is what everybody says. Then there's Gemini, there is Olympus, and then hopefully this year we'll have a very big model out sometime this year. So this is a slide I thought I'll spend some time over here. Just a potpourri of terminology for everybody to just see and discuss here, right? So NLP, natural language processing, that's the main task that we use these LLMs for, right? Next is neural networks. That's image recognition is one task. Neural network is a technology that powers the LLM and deep learning basically, right? LLMs we already discussed. Then we have foundation models. What is foundation models? Do you know these foundation models? Have you heard? No? So all these GPT 1, 2, 3, as we said, this is one set of foundation models. By foundation models, I mean what we just discussed, right? Models that have read a lot of text and they are pre-trained to understand the language, right? They've understood the English language, the grammar. That's what the pre-trained foundation models are for. It takes millions of dollars to create these foundation models, compute power basically, right? And then what we do, we take these foundation models and then we fine-tune them for our purpose, right? So for example, GPT 3.5, GPT 4 are the foundation models. They have been fine-tuned to act as a chat model, as an interactive model, right? Then we get ChatGPT. Okay. Multimodal, what does that mean? Exactly. So we can use different data types, image, audio, and text, right? We are all very conversant with text, but we also are using images and audio nowadays. Do you know any models I just mentioned two for the images, right? Midjourney and DALL-E. Anything else is there? You guys can teach me actually, I'm not aware of anything. Bard is doing images, okay. Bing, okay, Bing and Bard, same thing. Sensity. Okay, I'm not aware of that. Okay, how about audio? Meta. Whisper, okay, Whisper is by OpenAI. Okay, GPT again is the product, OpenAI is the company that made GPT. Okay, so Whisper. What does Whisper do? speech to text, right? There is also text to speech. Can you comprehend what text to speech would do? Right? So voice, you generate voice in somebody's style, somebody's tonality, and so on, right? So that's multimodal part of it. Parameters we have discussed already. Okay, I should shut up, right? 258, okay. Parameters, we know embeddings, converting input to a numerical vector format, right? Input being text or audio or video. Computer or these large language models cannot understand that. We need to convert to a vector space, right? And that kind of leads me to vector DB, right? These embeddings get stored into a DB. These embeddings are nothing but a point in a multidimensional vector space. And then we store them efficiently in a vector DB so that we can search for similarity very fast. Right? That's the whole point of inner crux of vector DB. Right? RLHF, okay, reinforcement learning from human feedback. Everybody knows, I will not talk about that. DPO, have you heard? Direct preference optimization. So that's a new alternate to RLHF to align the models, make them more aligned to the objective that we want for the purpose. So I'll not get into that. Emergent behavior. You know what is emergent behavior? Patterns it recognizes and then extrapolates, and we think that it has quote unquote God-like properties, right? Or, okay, I shouldn't go to God, quote unquote human-like properties. It can think and extrapolate what we didn't expect it to know, right? That is emergent behavior. It is getting intelligent or sentient. That is the emergent behavior, which we are seeing little bit sparks of that in these LLMs and models. Hallucination, creating data on its own, right? So basically some information that is not there as part of its training data, but these models give a very, very confident answer and you would believe them, right? So that's hallucination on these models' part. Bias and ethics. The bias that was there in the training data that shows up in the responses that we get from these models also. So when the point here being that when you use these models for whatever application you are creating out of them, you have to be aware, right? That's the practical part that I was bringing. You have to be aware that the answer that you get from these models will not be 100% accurate, right? And it will demonstrate bias unless you take care of it from your end. You cannot just blindly trust it. Then there is HHH. Any idea? These models are trained to be helpful, honest, and harmless. Okay? So the triple H stands for helpful, honest, and harmless. That's what we want these models to be. Explainability. We want to be able to explain, right? If you guys have done anything in machine learning, deep learning, you feed a image to a model and it says it's a cat, right? We know as a human how to explain why this looks like a cat or why this doesn't look like a cat. But a machine, a deep learning model or a Gen AI model will not be able to tell why it's a cat. Right? So that's the explainability part of it. Anthropomorphism. Giving human characteristics. So as I just said, kind of sentient behavior, we are saying that, okay, these machines are now becoming anthropomorphic. AGI, okay, artificial general intelligence. So that's where we want to go. Huge debate on whether we are there already or we are just about to get there or it's going to take a long time. So depending on who you talk to, you will get different answers for that. Singularity. Okay, machines overtake humans in intelligence. We'll pass there. And then Hugging Face, we already talked about that. So, okay, let me do it like this. Anything here you don't know you want me to talk about in the third column? RAG, okay. RAG, we'll have a demo on that, so we'll leave it for that part. Huh? Few shot learning. Okay, that also we'll cover in the demo. Vector database I kind of mentioned briefly. So it's similar to a database. A database is where you keep structured information, right? An RDBMS. In a vector DB also you keep structured information. You can do queries, you can do CRUD operations on the vector DB. So it's a DB that stores vectors, embeddings. Right? So there are open source as well as proprietary products available in the vector DB space. Okay, so I'll move on. Actually, I didn't come to many things, so I'll skip through this slide. I don't know if it's even visible. The idea being these 4 domains that we already kind of mentioned, Gen AI applications broadly in these domains. Within that, various categories of applications you can have. On the right side, we have names of some companies, products, and providers that we use for working in this Gen AI space. This is just another infographic showing the footfall on the various Gen AI-based tools available online that we can use. The larger the bubble, larger number of users for that product. Right? Also color-coded to the category of application that they are driving towards. Another view, personally I felt a little scary. Me being in Gen AI company, there is already a plethora of products available, but still there's plenty of work to be done. So this is where it kind of gets a little bit more technical now. Depending on what you want from your model, you can start with a foundation model, you can use it as is, or you can now start customizing it for your particular use case. There are various approaches to customize the model. One is you can achieve it through prompting, through prompt engineering. Right? That's the most approachable, most simplest way of customizing the model for your use case. If you want a little bit more out of your model, then you start doing fine-tuning or retrieval augmented generation, which is the RAG. Okay. So depending on what you want, you can get into that domain. Okay, I will just kind of, again, a little bit fun part. Prompt engineering, don't discount that. There is course available for $800 to learn prompt engineering. You can see here, right? If I move my mouse, do you see this part here? So that's $800 course on this platform. Then deeplearning.ai is a company by Andrew Ng. So they also offer courses in prompt engineering. Short course actually available for free right now, but I don't know which day they'll make it for profitable. Then Coursera obviously is also in the same bandwagon. Okay. Prompt engineering is a huge skill, as I said, it's worth learning. All of us should get better at our prompts. There's so much work done in the field of prompt engineering to make our prompts better. Even I personally used to feel that it's something very simple. You just be as concise in what you want, but now it feels like more and more you ask, more clarity you give in your prompt, more clarity you'll get in your response, right? So it's what you ask is what you will get, basically. So general tips, you can start simple. You will obviously never be able to create the most perfect prompt in your first attempt. You start based on the response, you customize your prompt, you add more and more information into your prompt to get more and more information back from the model. Instruct the model, basically saying you write something or you give me something, right? You instruct, don't just I want this, don't do like that. And then be specific. So have you seen prompts like you are an astronomy professor, and then you explain to me about the nebula in the universe, right? So you be specific in what you want. What is the role you want to assign to ChatGPT? Avoid impreciseness. Again, don't be very vague in your prompts. And last is to do or not to do. Basically, don't give prompt like, don't do this. Your prompt should be, do this. Be more positive in your prompt to ChatGPT. So there are various frameworks available. This is just the most simplest one. Your prompt can contain the instruction, context, input data, and output indicator. Okay, maybe I'll stop with this slide. This is just showing the prompt actually really matters. Okay. So if you see on the left side, if we give prompt like this, let's say our instruction is to summarize. We give passage and the text of the passage, and then answer, and this is where we want ChatGPT to fill. If we give our prompt like this, see where the accuracy is. Slight modification to that prompt, see where the accuracy is. From 3% to 80%. So with minimal aesthetic changes in the prompt, we are able to get a much better answer from these models as well. Prompting techniques. Okay, we'll see all of these in the demo. I'll not all, the highlighted ones, we'll see those, so I'll skip this part for now. These are prompting frameworks. Your simple prompt could have been like this on the left side. You modify it like this. You give your context, objective, style, tone, and so on. So that's a co-star. You give those, you'll get a much better response. Right? So just how do you craft your prompt? There's another one called CRISP. So you give the capacity and role, insight, statement, and so on. Right? If you guys want, I can share links to these, or even share these slides with you guys. Okay, LangChain, where are we? 310. Okay, I'll skip this part. LangChain, who doesn't know what is LangChain? Okay, so about 15 to 20% of the room. So LangChain is a framework that you can use to generate or to create applications. It provides you various modules which will help you to create a holistic LLM-based or these foundation model-based applications. Right? The modules that LangChain provides to us, listed at the top, models. It can interface with various different models we all use for OpenAI, GPT 3.5 or 4 interface, right? I think everybody talked about that in the morning. It provides interface to different models. You can just replace the model without worrying about too much the chain interface in your application. The prompts, it gives you some prompt templates, so it's easy to work with different prompts. Indexes is where you will store your memory and you make efficient search using the indexes into your databases, vector DBs in this case. Memory for saving your chat history, so it provides also a conversation buffer memory. Chains, when you want to do multiple tasks one after the other, output of one goes as input to the other, then LangChain provides you that chaining framework. And then last is agents, which are the components of this chain. Each one of those tasks is encoded as a tool. So there'll be a quick demo on that. Agents is the tools and agents is the same thing. So basically they sense the environment, they take input, and then they take action. And that's what a summary of an agent is. RAG, as I mentioned, retrieval augmented generation. It starts from retrieval. The purpose of RAG is to supplement the your LLM with extra information. Right? You all would have seen when you ask for something, you get a response saying, as my knowledge cutoff date is September 21, I can't give you an answer. Right? So OpenAI or ChatGPT didn't program, or as of now I see Jan 22. Right? So there's limited information. You want to supplement it with some proprietary information within your organization, then you use the RAG mechanism for that. Right? We'll see a quick demo of that as well. Okay, maybe I'll skip this. LLM ops is important. You guys can talk to me offline. These are various companies, products available in the LLM ops space. Moving on to LLM security. Your applications which you develop based on LLMs also have very, very broad security loopholes, just like your other web-based applications. So you need to be cognizant and aware of those as well. Right. Challenges, as I said, hallucination, knowledge boundary, so many challenges that these LLM-based applications will have that we need to be aware of, that we need to think about and provision for once we create a full-fledged application. Right, so some links I put here, obviously this is just 4 or 5 links I put here in a hurry. There is so much more information available online for all of us to see. Right, action items for you guys, keep active, be, in terms of all of you are here for the hackathon, participate in meetups. There's so many meetups happen online nowadays. after COVID, everything is online. So online meetups from associations in the US, right, which call people from, who are actually doing work in the space. So attend meetups, read research papers, hackathons, social impact of all these LLMs of your work you should be aware of. You can also put your product out on the GPT store as a GPT for a quick buck that you can make.
So can anybody tell me what is prompt engineering? Anyone? Absolutely. So it's a discipline basically to a set of instructions, right, with which we can get impactful responses from LLMs. Okay. So first of all, let's see why prompt engineering. So we have a very basic prompt here, let's say. So I ask OpenAI to complete this sentence, the sky is, right? Right, and it does, it auto completes perfect. Now, but when obviously you take your application to production, right, you want your responses to be in a certain format, you want to set the tone of the response, etc., right? For that you need to modify your prompts, right? So let's see a small change in the prompt. I put it here, complete the sentence in 50 words. It took my request into consideration and actually gave me, right? So obviously this is a very basic example, we'll go further ahead, but this is our simple change in the prompt, giving proper instructions can generate impactful responses from LLMs, right? So while this gets installed, I'll try to explain what all parameters we have here. I'll first ask one of you. Anybody here can tell me what the temperature setting does? Correct. So this setting basically controls the randomness in the response. The lower the temperature, more factual answer you will get from your LLMs, in the sense the next token will be highly probable. LLM will choose the next token which is highly probable, right? What is top P here? I know I've written it here, but yeah. Anyone? Okay, so this setting basically, if we do it, it controls how many possible words LLM can use to generate the answer. If I need to explain it with an example, let's say I have put temperature very low and top P very high, right? So what LLM will give me is a very factual answer, but very diverse vocabulary, right? It can choose from various possible words, right? So that is what top P is. Max tokens, you can control the length of your response. What is frequency penalty? Correct. So this controls number of time the word appears, right, in proportion to how many times it has already appeared. It's in proportions, right? The higher the penalty, the lower the chances of repeating a word in the response. What is presence penalty? Okay, so it's similar to frequency penalty, just that the penalty is a constant number, it's not in proportions. Basically, this is used to control how many phrases an LLM can repeat in its response, right? So, while calling any LLMs, we should make sure we configure proper parameters to get appropriate answers. Right. So we'll start with the very first method, zero shot or direct prompting. Basically, a very simple prompt. We don't give any examples or any SS instructions to it, right? The way we started using GPTs. An example would be, give me the sentiment of the below text, right? So this is my text. I think the vacation is okay, right? And it has given me the response. It's neutral, fine. Now, as I discussed earlier, you want to control the output, right? So then comes, that's all. This is zero shot. Then comes few shot prompting. Some of you were asking, ma'am. So basically, here what we do is, basically we perform an in-context learning or fine-tuning via prompts, right? So I have given few examples here. The first 3 lines are the examples. right? So this is my sentence, right? And this is how I want the response to be from LLMs, right? The ice cream tastes delicious. The sentiment of this statement is positive, right? So I trained it on these three statements. Then at the end, I asked it my actual question, right? Now let's see the output. The sentiment of the statement is neutral, right? Right now, if you can compare the examples which I trained the LLM on, it has actually given me in the same structure, right? It will not throw random words, random in the sense, right? Whatever we have trained on, it will actually give me output on basis of that, right? So this is few shot prompting, right, where we give it few examples, right, to basically tell LLMs how we want the responses, right? Okay, coming to chain of thought. Anybody here already knows what chain of thought is? So basically it encourages an LLM to tell us the reasoning behind its answer, right? It's as simple as that. Now how do we do that? There are two methods, again a zero shot way of it and a few shot way of it. Zero shot needs a trigger, right? So this is my question, right? Simple maths, went to the market, bought 8 apples, ate 2, bought more, right? Right. If I don't put this trigger, there's a chance LLM would just give me directly the answer, right? It won't tell me the reasoning behind it, how it derived the answer, right? But if you put this trigger here, let's think step by step. So what it does, it actually explains the reasoning behind it, right? Yeah. So it started with 10 apples, gave to the neighbor, so right now it has 8 apples. So this way, right, you can control or you can ask LLM to explain the reasoning behind their answers. There's a few short way of doing this as well, where we don't need a trigger statement. We do an in context learning, right? We give it this example, right? We ask the actual question here, right? Since it is trained on this example, it will follow the same approach and give me the reasoning behind its answer. So this is chain of thought, right? Yeah, coming to tree of thought. Anybody here who already knows what tree of thought is? So think of it as a human mind. So we have a problem to solve. We think few ideas, right? We do it trial and error. We right, execute one idea. We fail. We discard it. Move to another, right? So it tries to replicate a human mind, right? So I have this question here, right? So let's just go through it quickly. Bob is in the living room. He went to the kitchen. He took a cup. He puts a ball in the cup and took it to the bedroom. He turns the cup upside down, right? And the ball should have fell off the cup, right? And walks to the garden. He puts the cup down and went to the garage. So at the end we ask, where is the ball, right? Without tree of thought prompting, your LLM will not be able to answer it correctly, right? I used GPT 3.5 Turbo, right? It gave me the answer, but tried with few other LLMs. There's a chance it won't work, right? Yeah, so that's all. Mostly it will not work. So how do we fix it, right, with other LLMs apart from GPT 3.5? Sometimes GPT 3.5 also will give you inaccurate results. So the way we do is, like I said, to be able to tell LLM how to replicate a human mind. So again, there is a fixed prompt, right? So we ask LLM to imagine there are multiple experts working on the same question, okay? So those experts will analyze each step one by one. They will discuss amongst one another. At the end, if all experts agree, then it will return me the final answer, right? So this way we replicate the idea of human brain, where we have multiple ideas for a problem statement, right? So we do this. Let's see the output. So here expert 1 analyzed these 2 steps, right? 2 and 3 did the same, right? Now expert 2, the reasoning was Bob turns the cup upside down, right? At the end, expert 3 and expert 1 agreed to expert 2, right? at this stage, we concluded that the ball is finally in the bedroom, right? So this way, we can encourage LLM to replicate a human mind and actually, yeah. Any reasoning, right? Any analytical question you ask, most probably LLMs won't be able to answer it correctly, right? Just to lower your probability of getting an incorrect answer, it's better to use these kind of prompting techniques. Yeah. Okay, right. It will help. It will help. We'll see in a demo also. I have for that as well. Cool. So this is the final prompting technique. Anybody knows already what is React? Not the JavaScript framework. Okay. So it basically combines the reasoning and the actual action of it, right? So that's the core idea behind the React. We'll understand directly with an example, right? So this is a few short example trained in context fine tuning. So let's say our example is to build a house, right? Now, it's obviously somebody needs to build a house, right? So he will think, okay, I need some wood logs, right? How to get the wood logs? He'll go to the forest, right? And he'll observe the forest, right? So these three things, you will find a pattern here: thought, action, observation, right? A thought comes to our mind, we'll see how to do it, and when we actually do it, we'll observe the environment there, right? So likewise, went to the forest, chopped down a tree, come to the observation, tree fell. Now what to do, right? He has to take the wood logs back, right? And he has to place them. Flooring is done, right? So this is the React, actual reasoning and the actual action. So if we do this kind of few short training on the prompt, and we give it a task to perform, it actually replicates. Again, it's a few shots, so it will do it, right? So I asked him to book a flight, right? So it said it should start by looking right for the available flights. Then it will open a browser. Then it will observe, okay, open the browser, search for there are many flights now, what to do, right? So these three will repeat basically, right? Now this also sets our basis for custom LLM agents, where we can actually tell LLM how to perform this action, not just output it, right? That's what we will see next. Okay, before that, small demo on CoStar framework, right? Right. Obviously, now to take your prompting skills to the next level, there are two frameworks, CoStar and CRISP, right? We'll go through it. So CoStar means you need to tell your prompt the context, background information, objective, what you want it to do, right? How do you want it to write, right? As a typewriterist or something, right? You want to set the tone of the response, audience, target audience, and the response format, right? So, for example, we wanted to write a Facebook post to advertise a new product, right? Without this framework, right, you will see it gives me this response. While this is adequate, but you will see this is pretty generic, and this won't resonate with company goals at all, right? This is very generic in nature. Now the same, we applied CoStar pattern to it. We properly gave, right, what we want to do, what is our objective. I wanted to write in a similar fashion where similar to what big companies do. We want it to be persuasive so that people actually buy it, right? We tell it the audience, and we ask him to write the Facebook post. Now when we apply this pattern, now if you read through it, you will observe, right, it has significantly improved and very targeted and effective, right? In a similar fashion, there's one more framework called CRISP. right? You can define how do you want LLM, in what capacity or role you want your LLM or ChatGPT to function, right? As a copywriter, researcher, whatever, right? Again, you give some background information, you tell it what to do, right? You tell the personality, you want it to be business-like or casual, formal, whatever, right? And the only differentiator here is we ask it to return multiple responses, a human-in-loop kind of thing, where the final output we decide whether we want a combination of all the experiments or we want to pick any one of them, right? Again, some example, we ask it to write a LinkedIn post. Again, it's pretty generic, right? No one will resonate with it. We applied the CRISP framework to it. Now it's much better, right? So there are many other prompting tools, but we just covered very few of them, the ones which are important, right? Now coming to the next segment, we will give a short intro on what LangChain is, right? Most of you already know. I'll just quickly go through it. Right. So basically, it's a framework that helps us create Gen AI applications, right? Instead of focusing on each type of LLM, their coding style, etc., we can actually focus on business use cases and use this, right? So a simple example how to create a prompt. This is just a string replace. So we have a template here. We pass it a player. It gives me this prompt, right? Okay. Now we can, okay. As the name implies, chains are the core to LangChain workflows. So they can combine multiple LLMs, right? Output of one LLM can be input to another LLM, etc. So a simple chain can be created using this syntax, where we have only one LLM, chat OpenAI. We pass it to LLM chain, and we ask it to suggest a good name for a company that makes a podcast player, right? And it does that. It gives me this. Now there are a few utility chains. It's a PAL chain. We give it some mathematical questions. I think somebody asked. So again, we ask if my age is half of my dad did. It's going to be 60 next year. What is my current age, right? This kind of questions, it's always good to use this kind of chains. What the internally does, with respect to PAL, it generates a Python code and it's executed in REPL and it gives me the response. There are other tools like LLM Math, which actually does chain of thought and comes to an answer, right? So these are predefined tools given by LangChain, LLM Math, PAL chain. There are many more, right? But yeah. So let's say for the same question, it already knew it has to use a calculator, right? Now once coming to the final answer, it goes a step ahead and actually confirms, doubles it and checks, if this 60 and this 60 matches, right? And that's how it ends its loop, right? If you see the prompt for it, it will be a chain of thought, a react, question, thought, and action, right? We'll cover this, how to customize this action. Now similar to this, we can load multiple tools as well. Here we use Wolfram Alpha again for maths and SERP API. This basically you can consider it a Google search. Now previous questions we were kind of hard coding this 60 here. Now we take it a step ahead and we told, right, next year my dad is going to be same as some person, right, some celebrity. Right? Now what's the current age? Right? Now again, this chain applies the React pattern to it. It actually first searches what is this celebrity's age. It will first resolve this, right? It goes to Google search. Okay, she's 61 years old. Gets an expression, Wolfram Alpha, then resolves it and find the value of x, which is my age, right? So this is how you can combine multiple tools as well to basically, as per your use case, you can combine as many tools as you want. Right? Again, coming back to chain, I told we can configure multiple LLM agents. Output of one agent can be input to another agent. So that's what this is. our same question, my age. Now what we are asking, as per my age, this chain has to recommend a gift to me, right? So, and we just pass it on to this array, like execute chain 1 first, then chain 2. This way output of this will be automatically be an input to this, and yeah. So again it goes to calculator, it guesses my age, right? And at the end, chain 2 runs and it suggests a good gift for me, right? So this is how you can chain your agents or LLMs. We can, right, if something is not a variable which we want our LLM to resolve, we can make use of simple memories. Basically, let's say we don't want to hard code our budget here in the prompt. We want it to be different as per our use cases. So, so what we do here is, if age is under 10, gift should not cost more than this budget. Otherwise, it's fine if it is 10x, right? So what it does is, it resolves this variable from simple memory, right? Rest everything is same. Again, goes to calculator. It takes my age. Then yeah, suggests now my age is 30. So a nice watch, which is obviously most probably will be more than 1000 INR. Yeah. So this is a simple LangChain intro, basically a framework which you can build on top of multiple LLMs. Focus on your business use cases rather than directly going through each LLM's documentation, figuring out the syntaxes and all. This, it can do it for you. Right. Okay. So in React, I told we'll actually see how to perform the action. Let's say this action, right? It gives me this action. Now, how do I actually tell it to open a browser? Right. So I prepared a simple example for it. Okay. Again, making use of LangChain. The overall goal of this prompt statement is, from a natural language, it should perform some action, right? So let's say I ask it to create a folder named this. Inside this folder, create this file, right? Now, when I execute this, it should actually create a folder here, right? So how do we do it? Let me just reconnect it. Okay, we'll go to the syntax first. So the way we do is, we define our tools. Basically, we tell LLMs how to create a directory, right? So basic subprocess, mkdir operation, everybody will know. The way we create a file, we perform, we execute the touch command and it creates a file for us, right? So like this, we create multiple tools. We tell LLM how to do this. So we have an array where we put all the tools we want LLM to leverage, right? We pass it on to our agent. Then based on, now this is very important, we have to put a proper description to, here the function name, variable names in this description matters, right? Based on this only, it will reason what function to use. If these are not proper, LLM will not be able to figure it out. Right. So let's say if I say create a folder called this, and I put a proper description to it, right, it will actually use this function and create this directory for me. Let's run it. So this is our tool. We initialize our LangChain. Right. We initialize our agents, and we executed the agent. So if I refresh this, see, it has created the folder. Now you can take your creativity and create your own intelligent agents. Right. Okay, so the final is RAG, basically retrieval augmented generation. Can anybody tell me what's the difference between fine tuning and RAG? What is fine tuning? Sorry? Okay, in general, what is fine tuning? What does it do? Okay, so good. So RAG, what it does, it does not fine tune, right? It basically combines the powers of retrieval and augmentation, right? Retrieval in the sense we talked about vector DB, where we store our embeddings. When a user input comes in, we create a vector of it. We goes to vector space in vector DB, do a simple cosine similarity, retrieve the chunks, send it to LLM for augmentation, right? So this is how basic RAG works. Right. So here in our example, let's say we have this simple text, basically the New York Times article, right, where they tell this you OpenAI, right? So we'll see how we can ingest it and perform QA operations on it. We'll go to the syntax first. Okay, again utilizing LangChain, they have variety of tools for chunking, file reading, etc. We load our file here, we chunk it, right? We cannot send the entire file to a vector DB. We need to chunk it before we send, right? We chunk it, we create embeddings, we use OpenAI embeddings. We didn't use a vector DB, we use FIS. I am sure people will know. Simple similarity search, right? Right. So before fine tuning, if I run this, right, okay, let this finish. So basically, if you ask this question to ChatGPT, why did New York Times sue OpenAI? It will say it is not trained on it, right? As of September 21, New York Times has not sued OpenAI. To expand its knowledge, what we do is, by leveraging vector score, we enrich the prompt itself with that information. Okay. So in this retrieval chain, we send it a retriever, which is basically a vector store. So instead of going to its training data, it will use this vector store as a retriever. And since we have ingested this file, it will try to reason on that file instead of what it has actually trained on. Let's see if it is finished. It's still running. Okay, we'll see the output directly. Right. So when we do this, we asked it a query, the same query which we asked OpenAI. Now it gave us the correct result, why it sued OpenAI, because now we have enriched the prompt with this information, right? So this is what RAG is, retrieval augmented generation. Right? You retrieve specific chunks, you send it to LLMs for augmentation. You can, so there are many ways to improve it. Here we are doing a simple text splitting. You can do context-based chunking, right? So that it actually preserves the context. It does not send to multiple chunks, right? You can improve, okay, so there are two main parts of it, retrieval and augmentation, right? Now these are, in this example, both are not linked to one another. Generation is dependent on retrieval. It cannot give a feedback to retrieval if the retrieval is wrong. That's where you can use LLM agents, kind of create agents for retrieval and augmentation. So if augmentation layer feels if retrieval is wrong, it can actually give a feedback to the agent and do the retrieval again. So that's how you can further optimize it, right? Yeah. So okay. So this is done. We'll import our statements. We will run this. At this stage, we are basically loading doc to text in a vector DB. Sorry, we are splitting here. Once we split it, if you see the data, you will find array of chunks, not the entire file. We put it to vector DB. Okay. Our data is ingested to vector store. Right. So this example, before actually connecting LangChain to this vector store, we did a call. So OpenAI saying New York Times did not sue, but we all know it sued. Right. Then, yeah, we'll just. So here we asked OpenAI to use this retriever. Now you can see it will actually use that data to answer this question. It has answered. So this is how a simple RAG works.